Time to discuss the measures that you're going to use in your quantitative methodology. The measures are the hardcore data, right? These are the empirical proof. What are you looking at? And you're measuring it, right, with a ruler or a scale of some sort. So what is it exactly that you're measuring? These are also called your variables, okay? Very important, variables. Variables deal with the variance of measurements. In other words, the difference in the measurements. Why are some people high? Why are some people low? Right? That's the variance. The values vary. And that's what you're trying to explain, what's causing the variance in the variables. That's what statistics is all about. This slide is really important. Just make sure that your measures, your variables, are easy to see, right? Make sure they're easily identifiable so nobody has to question what exactly it is you're measuring. And after identifying the variables, my hint is make sure you let the readers know what types of variables they are. Remember your statistics courses. There are 4 types, and we use 3 of them, and I'm going to go over them real quick here. The reason why I identify the types is because that tells us what test to use. It's very important, and the reader should know it as well. So, nominal categorical. That is a partitioning variable. It puts everybody in the study into a pigeonhole, right? It groups them. So everybody that's in a group, right? So this guy is in group 3, but he's not in group 4, etc., etc. Everybody is in one and only one category. That makes it a nominal or a categorical or a grouping or a partitioning variable, right? The next one is an ordinal variable. An ordinal variable is described by the name, right? It's ordinal. It's rank, right? Ordinal means order in mathematics, and so does rank, right? Think of military rank, right? The higher the rank, the more power they have. So that's how these things work. And let me give you an example here. I'm going to make it personal. So let's say you had a question that said something like, how long do you sit in front of a computer every day? For me, it would be a 5. In fact, it would be a 6, right? I spend all day long in front of a computer. But some people, they have outdoor jobs and they're not in front of a computer. They would do very little. So how it works is the higher the number, the more prevalent or the stronger the characteristic of whatever it is you're trying to measure, right? So ordinal rank, again, you've seen this a lot. And its official name is the Likert scale. I believe the guy was German that invented it, and that's the way it's pronounced, Likert. Again, you've seen these a lot. So this would be, how strongly do you agree with this statement? I love chocolate ice cream. And again, if you don't like chocolate ice cream, you would strongly disagree. That would be a 1. And if you loved it like me, it would be a 5. In fact, a 6 or 7, because I really like chocolate ice cream. All right, keep moving on. An important part of ordinal variables is this. It puts them just in order. We don't know what the difference is between the number 1 and the number 2, or the number 2 and the number 3, etc. Right? There is no fixed distance. So think of it like this. This could be an order of who came in first, second, third of a race, right? So this guy is right here. He's number 5, but he could be like a mile back as long as there's nobody between him and number 4. So you got it? So the distance between the ranking orders is not clear. It's not fixed. It's all we know is that the bigger the number, the stronger the characteristic, okay? So just keep that in mind. The next type of measure is probably the most used one, I would see. That is your continuous variable. It goes by many names, continuous ratio scale. It's just a chunk of the number line, okay? So all that means is it has real numbers in it, like weight or how much money you got in your bank account or your IQ scores. Now, the big difference here is that it can have fractions and it can have decimals. It can have between numbers, right? It can have 4.6. That's a continuous variable. It's from calculus. Don't worry about it. And 0 in a continuous scale means 0, right? Like how many purple giraffes are there in your classroom? If there's 0, that means there's none. Okay, so a 0 literally means none. So that's true for this one. We're about to hit another one where that's not true. So, but let's keep going. And again, examples are height, weight, distance, time, right? Anything where you can have, where a number is counting how many there are, how many units there are exactly, and you can have fractions of units, etc., etc. Okay, moving on. This is the bad one. This is the one that they like to call the interval variable. Now, a lot of people get this wrong, and they're not wrong. An interval variable, we all know what an interval is on a number line, right? It's just, it's a chunk of numbers, chunk of the number line. In other words, there's a low value and there's a high value, and all the numbers between them is the interval. That's true. But in statistics, an interval variable is different. And I still hear a lot of teachers calling continuous variables and interval variables, but they're not, because I'm about to show you why. Interval variables only deal with temperature. As far as I can tell, if you're dealing with temperature, that has to be an interval variable, because the zero doesn't have a real meaning. That's how you differentiate between an interval variable and a continuous variable. Zero does not mean that there's 0 degrees outside. Got it? That means it's cold. That's all it means. But 0 doesn't really exist in this continuum of measurement. And it also has no, what we call, scalability. You can't say that 20 degrees is twice as warm as 10 degrees. You can't say that, because we don't know that for sure. It's very confusing, and my suggestion is don't use it. In fact, I've used dozens of different advanced statistics textbooks, and whenever they talk about an interval variable, it's always the same example. It's always temperature. I don't know why they go on about it. I don't think it's such a big deal. But again, my advice, don't use it. Moving on up. So with all this talk about measurements and variables, where are you going to get your data? And that's the answer right there. You're going to get most of your data from surveys. So surveys. So here's the part about surveys. Are you using a survey from a published article? Most of you will. Okay. That you find them in your literature review. So let's talk about those for a second. Number one is, do you need permission from the author to use their survey? Mostly that is kind of rare these days that you have to do that. But again, if you do, you have to let your readers know. Okay. Make sure you cite the name and the author and the year of the publication. Very important. A lot of people don't do this, from what I see, is if you do use a survey from a published article, the author should state their reliability and validity from their survey. They usually use either Cronbach's Alpha or maybe a Cohen's Kappa test, retest, reliability, something like that. And in the validity, there's no math part about the validity, but the author should mention something about construct validity. That means, is it a good test? Internal validity, external validity. There's a ton of different validities, but okay. But whatever the author cites, you should probably restate in your paper. Very important is, how old is the survey? A lot of these surveys were made in the 80s and in the 90s. Now, that was a long time ago. It was, before a lot of you guys were even born. So just keep an eye open for that too, right? So when was this survey made? If you have to, can you find something more recent? At least 20 years ago, 10 years ago, something like that. But again, do your best. Sometimes you can't. Sometimes you can. You got to tell your reader how these surveys fit into your study. Were they relevant? And why were they relevant? Now, my suggestion here is stick to the big surveys that are widely used. Example, there's a couple of big famous ones. I kind of forget the names, but again, I'm not a psychologist. I'm barely a statistician. That measure like avoidance, attachment, depression, PTSD, marital satisfaction, job satisfaction, stuff like that. There's major ones out there that have been used like 1 million times. So if you can find one of those, I would suggest you use it, because the reason they are well liked and well used is because they've already proven they're both reliable and valid. So go ahead and try to keep that in mind. Very important. If you're going to use a survey, know how to score the survey, and be very careful. There's some intricate things about scoring a survey. Make sure you read the direction. The number one thing is reverse coding. If you don't reverse code it, your survey is going to come out bad, right? And your data is going to be a mess and you're not going to get what you think you're looking for. But let's keep going. So with a survey, so let's take example depression, okay? And let's say there's 30 questions. You have the option, basically the author should tell you what to do. Now, normally you have the option to use it in more than one way. So you could use it as a single variable. So let's pretend you got 30 depression survey questions, and you would take a sum or an average. It really doesn't matter statistically which way you do either a sum or an average. You get the same results. But basically try to do whatever the author suggests, follow his orders. Now, what I see most people do is they do it both ways. They use the entire scale as a single variable, but if there are subscales created by the author, you can go ahead and make those too. You can get a lot more what I call forensic if you use the subscales instead of a giant scale, because some of the subscales might be very significant while the other subscales are not. So keep that in mind. Next slide. This one is important. There's a new move going on down through the world of statistics. It's called meta-analysis. What that means basically to me is you tend to stick to the studies that have the same effect size. So if they have similar effect size, that kind of groups them together. Remember, effect size tells you the percentage of the variance in the DV or the difference in the relationships, whatever you're looking for. Tells you the percentage that you can explain with your model. So the bigger the effect size, the better. So meta-analysis tends to group tests by their effect size. Keep that in mind. Now, when you're doing your a priori power analysis to find out what your minimum sample size will be for your stats analyses, called an a priori power analysis, we use G power, you're supposed to use the same effect size that were in the literature that you got your surveys from. Keep that in mind, okay? Moving on, did you make your own survey? Which is fine, a lot of people do. First thing they're going to ask you is, why did you make your own survey? You couldn't find a published version of your survey? Sometimes you can, sometimes you can't. I worked with a young lady once who did baseball stats. And there was a ton of stuff on baseball stats, but there was no surveys out there. And she had all these real interesting questions. And so she made her own, right? She did a great job, too. All right. Did you follow ethical procedures? Remember, surveys, ethical format, Alliant has the rules and regulations. In fact, we have a department that will check, and we call that the Institutional Review Board, the dreaded IRB. They are the police. They will tell you if your survey isn't good or not. So just make sure that you follow the procedures, right? So now, if you do your own survey, you need to check your own survey's reliability, either using the Cronbach's Alpha or the Cohen's Kappa inter-rater reliability, and then the validity, right? So again, address construct validity, internal validity, external validity. And if professors want more than that, then you can go into more detail about validity. And since you're talking about validity, you got to talk about threats to validity, right? So anything that might influence the outcome of your results. And the way I look at validity, it's kind of like it's more of a common sense kind of thing, right? So like the construct validity is, do your survey questions measure what you're trying to measure, right? That's up to the creator. But let's talk about them. External validity. These are the kind of things that can mess with your external validity. External validity is if you gave a survey to your classmates. So let's say you had 20 people in your class and you gave them a survey on, what they thought about the tuition of the school or something, right? They're all going to have one different outcome. Is that outcome going to be equal if you gave it to a different group? Let's say a bunch of people that work on ships, right? People that build cars. Will they have the same results as the college students? So in other words, it's got to be generalizable from whatever sample you had to anybody in the general population. And if it's not, that is a threat to external validity. And here's some other things. Sampling bias, right? You're picking your sample based on, what you want to try to get out of people. Like, if, again, the tuition survey, Yeah, it kind of is important to give it to people that are paying tuition, right? That would be the students in your class. Situational factors, different situational factors could get different results in a survey. Interaction effects, and again, same thing, all of these can threaten the external validity. Internal validity, on the other hand, is basically how well the survey was put together, right? Make sure that there's no confounding variables that might be influencing the results, right? So you just look around. It could be age, it could be income, it could be gender, it could be ethnicity, it could be anything, right? You don't know, but you should check. And then external events is something that's happening outside of your study plans. In other words, let's say there was a war. Boom. All of a sudden, your country was in war. Boom. That's going to really affect everybody's depression levels. So that could affect the internal validity as well. So maturation, also called aging, something like that. In other words, if somebody is taking that survey more than once, right, they're going to get used to the survey, and that's going to screw up your results. Researcher bias, again, that is bad. Any kind of bias is bad. But if the researcher only, he's writing the survey strictly to try to milk out the information that he knows he's going to get, that again is a validity, and those are all bad. Winding down here, the last thing we're going to talk about is construct validity. In other words, are the survey questions measuring what you think they are? Okay, that's not always true. Here's an example. You could have a rating scale. How much do you like orange? Right? 1, I hate orange, and 5, I love orange. But the question isn't quite clear. Are they talking about the color orange or the fruit orange, which I happen to like both, right? So, but again, the questions might not be clear to the reader, okay? And then if you're expecting something, you could expect that the cows come home, but that's why you do the statistics on it, right? You let the data tell you what's really going on. But if you're expecting something else, that could affect your construct validity, right? It could reflect in your survey questions. And again, subject bias, you're trying to manipulate answers from your people, from your participants, and again, that's any kind of bias. Bias is bad, bad, bad. And there's a lot of other different possibilities to threats to construct validity. But I think that's it. Let me check. And yeah, we're at the end slide. So that's everything there is about measurements. Remember, measurements are variables. And I hope this helps. And keep on keeping on.